Welcome to the second of three webinars sponsored by the NCAPA team, that's the New England Canadian Provinces Alliance, in our winter-spring series entitled Rivers, Dams, and Climate Change, the Good, the Bad, and the Ugly. My name is Hans Neu. I'm a semi-retired business owner, educator, and never-retired environmentalist. NCAPA is a grassroots network team of the Sierra Club, composed of volunteer activists both in New England and the Canadian provinces, and we welcome you to join us. We acknowledge that we live and work on the ancestral lands of the Wabanaki people who still inhabit these lands from Newfoundland, Quebec, and Maine, and the Northern Inuit of Labrador, the Southern Inuit of Labrador, and the Innu Nation of Labrador and Quebec. We are grateful for our partnership with the Wabanaki peoples and our engagement with members of all the other Indigenous peoples of Labrador, Quebec, Newfoundland, and Maine as we together build a more sustainable, just, and equitable future for us all. NCAPA continues to build upon the work of NAMRA, the North American Megadam Resistance Alliance, and the works of Hans Neu, whom we will learn about today, and Stephen Kasperzak, a fellow Mainer and researcher whose book, Arctic Blue Deserts, informs much of what we do. It is our contention that the current public perception and that of public policy of most but not all hydropower as clean, green, and renewable is grossly misrepresenting the truth and needs to be corrected. These are the goals to which we have devoted ourselves: public education, organizing, public advocacy in multiple countries, and growing the international movement for repairing the extreme damage to the environment, the peoples, and the cultures which have been decimated by this form of power production. When you take an unbiased and close look at the extent of these impacts over time, it becomes amazingly clear that megadam hydropower is neither clean nor green and certainly not renewable. And we believe we have proof that the extreme environmental damage created by megadam hydropower is a major unacknowledged contributor to climate change and the rapid warming of the Arctic Ocean, Hudson Bay, the Gulf of Maine, and the melting of the Greenland ice cover. So in a few minutes, I will introduce Roger Wheeler and our topic for tonight. But first, I wanted to make a brief introduction myself of the work that we're doing with NCAPA. So there we go. I'm going to share my screen. Can everyone see that? Okay. NCAPA, the New England Canadian Provinces Alliance, is a nonprofit volunteer-led organization working to build the movement about greening the washing of megadams while promoting clean energy, scientific truth, and climate justice. So I talked about that a little bit already. I'm sure this is probably not news for everyone who's here, but of the many different types of hydropower, we're differentiating among two of the main ones, one called run of the river and the other one called dam impoundment. Run of the river, a good example is Niagara Falls. The river, part of the river is diverted, but it is not impounded by a dam. And that part of the river is used to generate electricity while the river flows on unimpeded. Impoundment dam hydropower is very different. And that's where the problems start to come in. And just to give you a sense of the scope of the issues, here is a map of the dams in Canada. Okay, we're not talking about one or two dams on one or two rivers. We're talking about dams on all the major rivers in Canada and Siberia, which are flowing into the northern Hudson Bay, the Northern Ocean, Arctic Ocean. Roger's going to go into this in more detail. Okay, and here I'm having the problem again of my slides not going forward. So I'm going to go back here. Here we go. Okay. So Canada has almost 1,200 large dams, with 20 mega dams on major waterways and multiple dams and long diversions on many rivers, which are feeding more impounded waters into the dammed rivers. This is not a small problem that we're facing. So here is the nub of it. We're identifying 5 vectors of climate change that are coming from megadams. And Roger's going to go into this in more detail. I'm just listing them here so you get a sense that it's not just one thing that happens when you impound a river with a mega dam. Heat pollution, increased evaporation, ocean malnutrition, greenhouse gas emissions, and reduced albedo. So one of the major issues that's talked about in the work of Stephen Kasperzak is the loss of the spring freshet in the rivers flowing into the Arctic. And Arctic-bound rivers are very different from other rivers in that they have this phenomenon, which is called the spring freshet. So I'm going to show you exactly what that means. Here's my hand-drawn example of an Arctic or subarctic river. Key points: it flows in the summer in its natural state. It's frozen in the winter. And at some point in the spring, when the earth and the land is warming up, you get the spring freshet. And what is the spring freshet? It's a snowmelt of very large proportions, an annual high water event on rivers resulting from snow and river ice melting. And the amount of water, Roger's going to show you a slide which will show you in very dramatic detail the amount of water and the amount of energy that flows into the ocean from the spring freshet. It's very telling. Okay, what else do we have? Here's what happens when you dam a river. Okay, the former river, now dammed, is created a new inland sea, which we call a reservoir, in order to create hydroelectricity. And so we've got hundreds of thousands of acres, hundreds of thousands of square miles of land which have been flooded since, the middle of the last century, that is now evaporative uh, sources of water vapor into the atmosphere. This was an article last month in the Maine Sunday Telegram. It was a very large article. It spanned several pages. No easy fix for a ground fishing industry in decline. Of course, they're talking about the ground fishing industry in Maine. It's true in Canada as well, and I'm sure it's probably true, in Russia as well. And the having read the article, this is the summary of what was talked about. Reasons given for the decline of the fishing industry in Maine. Okay, and the only one which was not talked about at all in the article was the last one. And that's what Roger is going to give you in much more detail. So, next up, we have Roger Wheeler. Okay, and just tell you a little bit about Roger. With longtime family ties to Sebago Lake, Roger and his family moved from North Carolina to Maine in 1986. He was a Maine public school teacher until his retirement in 2017. He became involved with the Friends of Sebago Lake in 1992 and has served as its president since 1998. For many years, Friends of Sebago Lake has been active in promoting flow regulation by dam owners that more mimics the natural seasonal river flows and the lake level annual cycles. Friends of Sebago Lake's historical research of Maine's fisheries was key to a 2008 United States Supreme Court decision that required restoration of adromenous fish to their historical inland ranges. Friends of Sebago Lake's mission expanded during the relicensing of the eel weir at Sebago Lake to include holding regulatory agencies responsible for assessing the impacts of dams on marine ecosystems. Friends of Sebago Lake, in partnership with other organizations, is now working on a large project to collect and present scientific and historical information on the gamut of impacts of dams, including marine ecosystems and the climate. Roger's other pastimes include helping with his 6 grandchildren, and making wide-board furniture from salvaging slabs of lumber from very large dead or dying trees that would otherwise be burned for firewood or chipped. So with that, I give you Roger Wheeler. And Roger, you want to share your screen for your slides?
Okay. There we go. Let me move this up. Okay. All right. Can everyone see that?
Yes.
Okay. Here we go. Thank you, everybody, for joining us. The 3 warnings of Hans Neu. They're about the impacts of subarctic and Arctic hydroelectric dams and the ecosystem collapse and in climate change. Hans Neu was a senior research scientist at the Canadian Bedford Institute of Oceanography in Nova Scotia. He was a specialist in coastal and estuary dynamics, and he studied waterways across Canada, continental shelves, and the Northwest Atlantic. Neu warned that the impacts of the subarctic and Arctic dams would bring destruction of Northwest Atlantic fisheries, heat pollution of the atmosphere, hydrosphere, and cryosphere, all forcing climate change, losses of river flow energy resulting in weaker ocean currents with global climate implications. Now, early on, his talents were well recognized, and he was this newspaper article touted him as the undisputed authority on the Atlantic's moods, where he did a lot of his work. This newspaper article in 1966 talked about him and his study and how the holding back of water by dams and actually had changed the climate conditions since the turn of the century. He also suggested that these dams be regulated, that no new projects be permitted until their effects on the ocean were known. That didn't go over well with the hydropower industry, I'll tell you that. Once again, I'm going to just elaborate on the spring freshet. It's important to understand it and the impacts when it's stolen by large dams. You know, that spring freshet is the annual spring flood rise of streams in cold climate when seasonally higher temperatures melt the snowpack in a relatively short time period. Now, Neu understood that the seizing of the spring freshet by Arctic and subarctic storage dams and releasing waters the following winter would do the following things. They would undo the balance of climate regulation. They would starve fisheries. They would create multiple pathways of heat pollution. They would stagnate saltwater and freshwater layers, and they would affect the ice conditions. Now, the map in the upper right there is of the watersheds of the major rivers that flow into the Arctic. They all have large dams except for the Yukon. And they pump water into the Arctic Ocean in the winter, and it's no one knows what the impacts are. It's also important to understand the hypolymium and hypolymial releases from large northern dams. Water is most dense at 39 degrees. And so that's in the hypolymium, that's the temperature of the water. These Arctic megadams have to have large reservoirs to create this hypolymium so they can run this warmer water through their turbines. Otherwise, things would freeze up when it's minus 50 below. Now, this is a photo like at Hungry Horse Dam, 15 miles west of Glacier National Park, built in 1952. Now, in the unregulated river of the South Fork below it was 32 to 64 degrees. Post 1953, it didn't really get above 45 degrees. It stayed that about most of the time. You got to wonder that all that water vapor coming off the reservoirs didn't affect the Glacier National Park and the glaciers. But that's when the glaciers started to melt in the 50s, according to reports. Now, Neu did a study of the ice conditions of the Gulf of St. Lawrence. The purpose of it was really for navigation, but he kind of had a Houston, we got a problem moment coming from it. You can see where the Manic 5 reservoir is in that old meteor crater. Um, Now, the Daniel Johnson Dam creates the Manic 5 reservoir. That's an example of a mega dam. Uh, Before the Manicouagan, sorry, Roberta, um, in a in a few weeks, water could flow from the mountains to the St. Lawrence estuary. Now, because of the dams, water can take 8 years to cycle through the reservoirs. The thermal regime and chemistry of the river water is radically changed. But these are a lot of these dams are now cascading on rivers. The Manicouagan is a primary example of it. The large dam at Manic 5 stores the equivalency of 27 Moosehead lakes. Now they don't dump all, you can't dump all of it in the winter, but a huge amount goes out, is stored in the spring and then goes out in the winter.
And the Moosehead is the largest lake in Maine, isn't that correct,
Right,
Roger?
right. It's a big lake. Just a point of reference, here's another view of the study area, but I'm just showing where Point Au Pair is. It's a weather station. NOAA used the data from it to make the claim that the temperature in this region, in the St. Lawrence region, had increased since the turn of the century. Now, this is an important slide because it shows the spring freshet of the Manicouagan. Actually, it shows it. The red is before the dam went in, and it was used to be about 140,000 cubic feet per second on average. Now you look at the black line down low; it's what it is now, and you can see in winter it's the highest flow. So they've totally changed inverted the seasonal flows. This is a cross section of the St. Lawrence estuary at Point de Monts.
Roger,
Yep.
before you go on, could you just say a word or two about the impact of the loss of the spring freshet on the ocean?
Um, yes. Yeah, I can do it probably with this slide. Uh, so when the fresh water goes out, okay, it goes to the right side in the St. Lawrence estuary because of the Coriolis effect. Um, and it's lighter. So as it goes out, it rides above it. It actually creates liftoff in its own waves, but it pushes down on the water column. So salt water at the bottom is pushed. It's evected back up into the St. Lawrence estuary, but it's also pushed down through deep canyons in the ocean. So you have a lot of water movement. Here's to that point. If you have less fresh water, you have less water movement, and Neu called it stagnation. So to that point, also at Point de Mont, where it funnels down, and kind of the bottom topography gets shallower, the salt water speeds up. And where he took his measurements, he determined that there was a 1 to 15 ratio of fresh water going out to salt water coming in. When you look at that, the amount of salt water coming in is Amazonian in volume. So that's what does the mixing. So to that point, you have less mixing when you lose these spring freshets. And if you have dam after dam causing less mixing, you have problems. So I think hope everyone understands that ratio, what's happening. So also, there's a map. You have Gulf of St. Lawrence down there. You have Hudson Strait up at the top left, and these freshwater currents come out and actually join with the Labrador current, especially the inner Labrador current. And so there's another impact, you have weakening of currents. You have less upwellings. And the Gulf of Maine's down there at the tail end here, and more of the tail end. So if you affect the strength here, uh, well, the Gulf Stream's just going to say, hey, I can go in here. The Labrador current is weaker. So that's another impact. And no
Weaker
one,
and warmer, right?
yes, sorry. Yes, good point. Weaker and warmer.
Because the water coming into the bays and the estuaries from the rivers now is a warmed water from the
Yeah.
impoundments behind the dams.
And and the deeper salt water is warmer. So if it's coming back in the winter, that's not a good thing. And that's what Neu was big about. You don't want that warmer salt water coming in the winter. In the summer, it's fine. I mean, the spring, because it's going to cool the climate. Now, Point Au Pair, I showed you that weather station in the study area. So here's what was Noe talking about? Here's a graph of winter minimum mean temperature. 1880s is when first dams went in, but there's a lot of canals. They were changing water courses a lot. But by 1930, you started to have some that cascading dams put in on some rivers like the St. Maurice. And pretty soon, the average winter minimum temperatures don't go below 12.5 degrees Fahrenheit anymore. And they just keep going. And it's the winter temperatures that are affected the most. That's why I use the winter mean, because it's dramatic. You know, the building of dams went from the southwest to the northeast. You know, the 1900s, the Maurice, St. Maurice in the 20s, Sanguinet in the 40s, and of course you had the others came along later, like the Manicouagan dams. Now, Point Au Pair, you take the annual average temperature, and I got a CO2 line in there also, thanks to IPA who did our software. It's there just to give you a reference to rate of rise. Now, we know that CO2, it increases. It's definitely going to increase it's going to get warmer. But the temperature of this region took off, and way above what it would have been CO2. So we say, okay, let's look at other places in Canada. What was happening? These are weather stations in Canada, but they don't help us much because they don't go back very far, or they're like a 3 or 4 years. But there's some that were you could use. And one being Prince Albert in Saskatchewan, Cujuara had some in Quebec. So we go and we look at Prince Albert. What happened to the average winter average temperature with a 93 hinge put in by IPA? It stayed the same. Okay, it's not what happened at Point Au Pair. In '93, I tried to do some research. It looks like there was some dams put in this region, but other things are happening too. So it rose then. But then you go to Cujuara, which is about 100 miles north of the Barrasso Dam, which was put in 1980, and you look at it, oh, it stayed the same until 1980, and then it took off. So it seems that dams can affect the temperatures. It's a couple things important to understand. Sublimation, in arid climates, let's say, I mean, there's Siberia. Before the dams, you had 5% humidity. Canada, it's very low too. So you had to have snowpacks would evaporate in these conditions, and it would cool the snowpack. But now you have condensation. Condensation, when the air is humid, the condensation transfers water molecules to the snowpack and warms it. We all know about foggy nights in the spring when it's still cold, and you know how the snowpack will melt during those nights. So we're witnessing warmer temperatures, more melting, and significant reductions in the snowpack. This is the Yenisei River in Krasnoyarsk. It's on a reservoir. The It's minus 30 degrees Celsius.
This
And
is
you,
Siberia, right?
yep, gone to Siberia. And the river, this never freezes because of the dams and releasing the hypolymial flows. So this is 24/7 going into the atmosphere. But it's really some of the water vapor that goes up that you don't see is probably the most troubling because it goes up into the troposphere and it's carried by 50-mile-an-hour winds to Lord knows where. So we've asked ourselves a question: is there a connection with the increased humidity from amps and apparent reduced winter snowpack, drier summer soil content, and increased numbers and intensities of fires? Because the snowpack is less, so it melts sooner, and things just get drier. Well, right above the where that arrow is, you'll see the Barasso Reservoir, and so we'll look at snowpack depth. Thank you, NOAA, for making this data available. Still hope it's available. In Kuujjuarapik, the snow on ground average tipping points for 1980 and 93. Now we use 1980 because the Barossa Dam was built. You'll notice that the average snowpack drops considerably at Kuujjuarapik. The Brisset came along in 93, and you're going to have who knows, you do have more snow or the same amount of snow, but you still have less snowpack because of the condensation. I want to give a point of reference here. You see where Kuujjuaq is in the lower left? That's a weather station on Gave Bay. Now it would be directly affected by the Kanesca-Piscau River in northern Quebec, where the Brisset amps cut it off, diverted it by 40-50%. So it might see a change there. Oh, so yeah, come 1980, it would still be affected by the Barasso, which is to the southwest. But come along 1993, when the the Brisset went into operation, there goes the snowpack ever since. Now go back for a reference to, you see Eureka up there. Also, Greenland, above Nuuk. I don't have an arrow, sorry to it, but that north of Nuuk took the Danish, thanks to an agency there, took weather data, put it together, and so we have some weather data on this side. This is where the most intense warming has been, on this southwestern side of Greenland, and the glacier melting. So now, because of CO2 and the models, I guess it's warming. At the rate of rise, according to the models, it was supposed to be in 2125 that you would hit an average of 0 degrees Celsius. But something happened about 1993. It shot upward. And now in 2013, we hit that threshold. Now, Eureka, which I showed you, is northern end of the Canadian archipelago up there, Nunavut. Interesting that it wasn't rising. The average annual temperatures weren't rising until 1993. Yeah. So what
And
happened?
happened in 1993, Roger?
The Brisset Dam went into operation.
Thank you.
It was there were other things happening, in Russia, but nothing that was close. But anyway, here's a map. It shows where the Kola Peninsula is. It shows where Canaan Nos, a weather station, is. You see where Dixon is. I don't have an arrow to it. It's Bratz down where Lake Baikal is in the southern center there for reference. Now, in the Kola Peninsula in 19 started in the early 1950s. They started putting in reservoirs and dams. They're fairly compact, one after the other, and it's key that it's right on the ocean, the Barents Sea, and they flow into the White Sea. So it'll have, the major impact on
Excuse
the
me,
ocean.
Roger. Just
All
for
that.
anybody who's wondering, AMPS stands for Arctic Mega Power Station.
So thank you. Sorry. Um, so we go to Canaan Nas, which is right near the Kola Peninsula, and there was a major increase in the precipitation right about in the early 1950s, as you can see. Okay. Dixon, which is about 1,000 miles away, there was still a change in 1952. And it really wasn't the sea ice conditions weren't really changing then. There wasn't, we looked, what else could cause this? Um, that was not as dramatic as Kane and Noss, but it did go up. But you'll notice in the summer, nothing really changes. It's not significant in the change. Now, there's one article from the Miami Herald in 1975. Um, it's a good article to read if you've got time. Huge man-made lakes warming up Siberia. They found that they loved the climate that these dams made. One official of a Siberian city said, "We used to have winter temperatures as low as minus 67 degrees around here. Now it's a rare day on which the thermometer drops to 40 below zero." That's a big difference. If you ever been in 67 will kill you. 40 below, you can maybe survive. Um, Now, we sort of switch to ecology of what's going on. This one article in the Sun Times in 1974 was one of the best explanations of what's going on. I'm not going to read it all, but just this little explanation here to summarize it. As the fresh water of the St. Lawrence tumbles into the Gulf, it acts as a pump on salt water, drawing in salt water from the sea through deep gorges and pulling it up to mix with the new water on top. The churning of the deep running salt water brings to the surface the nutrients from near the ocean floor, which fish and other forms of life need for food. The relationship of the two systems meant that the strongest flows of water, coming as they did in the spring, helped bring near the surface abundant quantities of food and nutrient. But damming of rivers has changed that neat interaction. It doesn't occur when they need it now. He felt that um, it would cause stagnancy. Stagnancy is the most poisonous condition of nature. And he said he had no proof. It was too complex to prove it, why it would starve the fish. But I think we now have some of those answers to why it does. Now, in the Gulf of Maine, we had this article by William Balch, a senior research scientist, and he stated that we've seen that growth of phytoplankton is about a third of what it was 20 years ago. That's a really big deal. Yes, that phytoplankton needs those nutrients. Also, these results reinforce the hypothesis that the observed decrease in surface Gulf of Maine primary production resulted from a switch from Labrador seawater to North Atlantic seawater entering the Gulf of Maine. Well, this switch occurred in that 93 time period when they really the freshwater flows were changed. And Neu was big on, he said, particular concern is the increased development of hydropower in Labrador, Ungava Bay, James Bay, and Hudson Bay, which are bound to threaten the productivity of the Grand Banks of Newfoundland. Now, Neu wasn't the only one. There were some other scientists up there also warning about this, fishery scientists. Now, the cod, guess what it did? It collapsed Actually rock bottom in 92. Amson Reservoir were built in the 6 years before that. Um, Other scientists predicted the collapse of the cod. Now you'll notice that it always came back from overfishing. They put a moratorium on it, but now it doesn't come back. Now, let me get rid of that. Diatoms, the diatom there, requires silica. If it doesn't have silica, the shell doesn't grow. It has to have it when it needs it. Silica makes it heavy, so it sinks to the bottom, taking its carbon with it. Um, that's why in geologic history, diatoms helped cool the planet because they processed a lot of CO2, got rid of it, but we know it as oil today. It's residue. Um, Neu taught us that dams reduce nutrient availability to phytoplankton diatoms in 3 ways. First, the silica is trapped behind dams. Two, it comes at the wrong time of year delivery of all the nutrients. And three, it generates weaker upwelling so that silica nutrients aren't brought to the surface. And there's more stagnation of the layers of the ocean, which diatoms don't like. Uh, the copepods depend on the diatoms, and the young cod and other ground fish depend on those copepods. The right whale, that's one of their staples, is the copepod. So if you mess with the diatoms, you're going to harm the whole food chain.
Roger, may I ask a quick question?
Yes.
So you would agree that the reason this is really important is because all of these species are evolutionarily adjusted for the time of the year when the water is supposed to flow. They haven't had sufficient time to evolutionarily adapt to this massive change. So that's why these species are so affected, is because they've been evolutionarily programmed for the water to be flowing at that time of the year. Would you
And
agree with that?
I would say more than agree with it because 95% of all ocean life, fishery, is dependent on estuaries. So this is where the biggest impact is. So like you just say, uh, eggs are laid in the estuaries, and normally they would be carried out to sea, uh, but this energy is lost. So I mean, or it just goes on young fish. They might have to work harder to get out the ocean, or be transported, or up and down. Vertical migrations change. Yes, so you're absolutely correct. That's a whole
Right.
science there, right? What you just mentioned.
Thank you.
Thank you. Okay. Um,
Hi, Roger, just can I ask you a question? This is
yep.
Roberta. Also, the idea that this water that is leaving a reservoir in the winter time, when most of this energy is needing to be generated, that water is warmer by maybe 2 or 3 or 4 degrees, whatever, when it hits the estuary. And I seem to have read somewhere that codfish eggs can not survive in the estuaries with a temperature change of ±1 degree.
Yes. That's why
So that's another issue.
those fishery scientists, Canadian, said that it would affect the ground fishing. Exactly. Just multiple pathways of pollution there that let's see. Let me get to, okay. Um, he said that Noy said if Canada and Russia continue their dam development, the hydrological balance of the planet would be threatened, and the biological productivity of the coastal waters and oceans would be at risk. Well, he might have been talking about the AMOC out there in the Atlantic, and but so. But anyway, I'm gonna just for reference. Here's Niagara Falls, 85,000 cubic feet per second. It's a big river. Okay, not the biggest, but it's a lot of water. Now, if we go to the Yenisei and the Obe,
Siberia.
Yeah, no, Arctic Ocean, Siberia, Kara Sea. You have a large, uh, well, they're heavily dammed. Um, so you have a lot of reservoirs. And in June, okay, the pulse energy and volume of 26 to 38 Niagara Falls, this is conservative estimate, I think it's more, flowing for each second of every day for the month of June never reaches the Kara Sea in that time span, as it once did through geologic Arctic Ocean history. Well, there's other rivers too, but this is going to affect everything. It's going to change the currents, and like you said, that's going to change currents as far as away as the Atlantic Ocean. Also, it just doesn't stay here. That's a lot of water that's got to come out in the winter. And one of my newest research efforts is to understand or find out about these plumes that are under the ice. Where do they go, and how do they heat pollute? How does it change the ice conditions of the sea ice? It's quite an undertaking. Keep in mind that you talk about heat pollution. For each ton of water that condenses, almost 2 million BTUs of latent heat is released to the atmosphere. So you put that water vapor in there, it's not just uh, water vapor affecting solar radiation. It's heat release. And you also have another factor in the Arctic. You have high winds. It's not unheard of, like in Siberia, steady 50 mile an hour winds. Here it says winds move water vapor and heat energy long distance across the face of the earth in a relatively short period of time. So going from, let's say, the Bracé Amps to Greenland is just, you do the math, it's not long. Now, here's a Washington Post article, snippet of it. This is sea level rise. It's a nice day, no storm, really causing this, just high tide. And, they're saying that last year the sea level rise increased about 35% higher than expected. Well, it's not going according to their models. They say this unexpected rise is concerning. But all the models don't talk about what the dams are doing. So everything is, it's got to be done. All this, the climate committees and states and federal, they don't even talk about Hans Neu or what he warned about. That's really all I have for now. I think I've got about half an hour, but I want to thank Steve Kaspernak helped with this, and NCAPA, and an army of people that helped with getting the information for this
Hey,
presentation.
Roger, I have one more quick comment regarding your last comment there, which is it's not just you said that it's not that they're including it in their models. The mega dams aren't being included in the models, which is obviously a clear omission. The problem is that they're actually including hydroelectric as part of their green energy recipe, right? So they count it. The state of Maine in particular counts that as part of their green energy solution. So it's not simply that they're not counting it in their models, but they're actually including it as part of the solution. So that to me is even more profound than what you said, in my opinion.
Yeah.
Thanks.
Okay. Thanks.
Absolutely.
Yeah. Anybody now? Any comments, questions too?
Yeah. Thanks, Roger. That's a great job for people who are data junkies. Great job. We got to realize what Roger said is trying to tell us that the entire hydrological hydrological cycle for the northern hemisphere has been altered to such an extreme on a number of levels, through heating water, through the evaporation, that science has stepped up and said, well, the polar region in the northern hemisphere is heating 4 to 5 times faster than the rest of the planet. But again, they're making no connection to the dams and storing water. And you mentioned cascading. For some people, they might not know exactly what that means. If you have a dam and below the dam you have another dam and below the dam you have another dam, which is very popular with these dam builders that do these mega dam type of dams. Every time you detain water, it gets warmer each time. And another piece that you mentioned, we have to consider that the reservoirs that are formed by these giant dams are actually storing summer in the water. It's being stored, all that sunlight. So we can say they're storing summer. Just a little more information.
Thank you, Cliff. Roger, would you stop
Can I
sharing the
mention
screen now?
also here, when you talk about cascading dams, the Churchill River, which we call the Grand River in Labrador, and that's why my group is called Grand River Keeper. The Churchill River has the largest or the second largest man made reservoir in the world, in the Smallwood Reservoir, and every single stream, lake, pond, everything that could be corralled into that was corralled with something like 130 dikes or more, and made that huge project, which came on stream in the early 70s. Then a few years ago, we put in the Muskrat Falls project, which is quite a ways downstream, down near my community, about 36 kilometers away. Now, Hydro-Quebec and Newfoundland and Labrador have a major plan to put another 300-foot dam at Gull Island, which will create 3 massive reservoirs. And like Cliff said, they will be warmer and warmer and warmer. They will be stagnant, and the entire 500-kilometer river will become nothing but reservoirs.
You
So I just want to bring that up for people.
stop sharing your screen, Roger.
Oh,
Wolsey.
but that,
Yeah.
like,
Let's see who's left on
stop
our.
share. I'll stop share. Okay.
Yeah, that would be great.
Okay. Thank,
We are open for questions. Where some of the members, there's so much information. We need a few people to remind what one of us may have forgotten. One thing that we're just now starting to realize about this is that we've noticed that water vapor travels, particularly when you have predominant winds, and it keeps traveling until it builds up a certain amount of nuclei in the atmosphere to get it heavy and condensate enough to then drop its whole load. So the water cycle that we're seeing on the earth is out of balance because we're getting droughts and we're getting torrential rains. Because that water vapor is being pushed. Our planet and all the life on it has been used to a certain water cycle, but that water cycle is now changed permanently. And what we're seeing, these extremes, drought and floods, is going to continue until we get a handle on the water cycle. Questions?
Thank you, Cliff. I'd like to acknowledge Kat Taylor.
Thanks, Halsey. Roger, great presentation. I mean, so much information. Yeah, so I have some questions, but I also had a comment. I was watching the news this morning, and they have this news center segment on weather weenies, so there's 2 meteorologists talking, so it's not really super exciting, but they brought up dirty rain because someone wrote in and asked about it, and they looked into it, and what it is right now, that's such a drought in the southwest of the United States that the weather, if you watch the weather pattern, it kind of swoops down and then comes up and swirls over New England and then goes out to the ocean. And what's happening is the dust from that region is being pulled up into the atmosphere with exactly what you're talking about, with the moisture so far high up. And then it's being dropped here in Maine. So we're literally getting dirt from New Mexico dropped in Maine. So it baffles me that people don't see the connection between what happens there and what happens here, because that could be anything, not just dust. It could be all kinds of pollutants
Right.
and they're bringing those toxins into our state. And so I was wondering, especially with the Cascade model, we're looking into in clean energy. We've looked into pump storage. I think Matt Cannon might have brought that up at a meeting, or he posted it somewhere. And I was wondering if you know of any news, and Roberta and the rest of you, that are up in Canada, is there any attempt on Canada's part to use the Cascade for pump storage, or use the water itself for geothermal? Because I brought this up with Bill Weber, who's the Portland Climate Council or Change something or other, and I said, why isn't Portland looking into that, where you could, instead of you're using heat pumps, which are taking the outside air, but if you took the air from the actual ocean, which is warmer, it seems to me that they could kind of tap into that like we do geothermal. So I was wondering if you've heard anything happening in Canada, if they're trying to modernize their systems, because I hear they're running out of natural gas, and pretty soon cheap hydroelectric will not be available for Maine. Jack Shapiro brought that up.
Hold on a second, Cliff. I guess Roberta has left.
Oh,
How
okay.
about Elizabeth Lee? Could you speak to that?
No, but I live in Newfoundland. I've lived all over Canada,
Hmm.
and I can't hardly listen to this because I just want to weep, because my father, he went mad. He was a vet and he had PTSD, and his whole life he was couldn't let it go. It drove him crazy, and he had we all had a hard life. But what I see in BC, they put 3 dams on that Peace River watershed. They actually buried in water anything from the Ice Age, because there's a section of northern BC that and Alberta, I think, yeah, and a bit of the Yukon. Don't ask me how, but it is, because I've worked up there. And that part has species that were still from the Ice Age. It missed that part. It's part of Canada.
Right.
So when they did the last dam, they just went ahead. And I think there has to be, the reason these things are going ahead is people want to work, especially men. And this is nothing against men, but they want to work and they want a good job. And so they work in these jobs. And I have done this as well at one period in my life. And so as long as we have this focus, these will go forward. And Canada is such a lazy nation in the sense of protecting its assets, protecting its beauty. I mean, they still are logging old growth forests in BC. Now, Europe would just love to have one old growth forest. It doesn't. Everything is replanted.
Yeah.
And it just goes, and they refuse. And it doesn't matter what government you get in. So this election is a farce.
Right.
Similar to yours. And so people have to realize that their children and grandchildren will not have a life of any sort, because in a moment, we're still snowing here in Newfoundland. I mean, we're talking blizzards. You go to bed, maybe 1 in the morning, I get up and there's a blizzard, and then it melts. Then you get another one. Nobody that I have met here has ever experienced that. And always the wind. Yeah. Always the wind. And the wind up here can go over 120 kilometers an hour. Well, I can just imagine that's going to be nothing. And so the northern will be hit the first, and then it'll move south. And then the people that enjoy all this special stuff, what happened? And they'll be laying blame, but they didn't care as long as they're comfortable. And that is the heartbreak of everything in the northern hemisphere. in the Western Hemisphere, I told my daughter, we have nothing to be proud of, right? Because you look at what we have done. Oh, it seems like, oh, our children, blah, blah. We go on, but it's not ever been sustainable. And my father never even talked like this, but I know that's what broke him because he knew this was the end. And he went to war and he saw such terrible things. So I think we have to. I'm so thankful because when I saw a dam the first time as a little girl, I thought this is the most ugliest thing I've ever seen. Nobody told me that. Inside of me, it is nothing but a body of water. It has no life. It has no substance. It has no story. You know. And so, and I'm not indigenous at any level. I'm so white. I'm whiter and white.
Yeah.
But I think we have to put out just the boldness
Right.
of one sense. We got to get our genius, and that's all people see. Like that's what Polivra does in our country. He just says a statement, but he doesn't. But we know what we're talking about. He doesn't. He deliberately does this to frighten people. But you know, that's what politicians do, right? But that is all we have. I mean, you can find out more and more and more and more. I'm sorry, I just feel I'm so heartbroken because water is life.
Yeah.
In any culture in the world that doesn't honor water except the Western culture.
Okay.
We have to put the finger on ourselves and say, yeah, I have grandchildren and great grandchildren. They have beautiful homes. They have all this stuff. And they are living in a dream world. And it sounds like a lecture, but I mean, we have to take all those words and put it like in a storybook and like they're all children because they're selfish. Our adults are selfish children. Old people say, oh, I'm too old to get out and put up a flag or walk through their communities. And then I go on the webinars and guess who? It's all us. It's all us, except for maybe Code Pink, you know, who has lots of young people. But sorry, I
think you're in good company here, Elizabeth.
I know, and it just breaks my heart because nobody had to tell me this, but I did water management. I worked with water management. I worked in the Arctic. I did so much stuff. I saw that Arctic. There is nothing more exquisite in Canada besides Newfoundland. And it's not connected to Canada. That's why it's like it is. Then the Arctic Circle. I mean, it's breathtaking. There is such wonder there that you can't speak about it. And that will go, and then it's all over. Who cares about
well,
you know,
hopefully
some
it's not
nice
too late.
park in Victoria, BC, or you know, I've been to Washington and I thought it'd be something. Well, it's not. There's a lot of poor people walking around.
I'm going to turn now.
Okay, I'm going to shut up.
Thanks,
Thank you
Elizabeth.
for letting me spout off.
Cliff, and then Roger, I have a question online on our chat here from Haley, so I want to get to. So go ahead, Cliff.
I'll let Haley take Haley's question first.
Okay, so she says, along with nutrient depletion and warming, are Arctic rivers seeing big issues with coastal erosion as a result of dams retaining sediment?
Yeah, and one of the reasons I asked that is because I think there are a lot of studies coming out now that like I don't know if it's as much of an issue in the Arctic as it is in other parts of the world, such as the Akasumbo Dam in Ghana. I don't know if there's the same sediment load, and you know, for example, in the Amazon, it's a big high sediment river. That's a huge issue. I don't know if they're seeing the same things in the Arctic as well, that you guys know of.
Could you give us an example?
I'm just going to say, you hit on a point, and I've studied some rivers. There's studies of it. There's less sediment coming down, and that sediment is moved all along the shores from these estuaries and the mouths of the rivers. So if you lose that, what does get down to the dams, because you lose the high flows that push it out and push it around, so sediment drops further upriver. So yes, you're going to get more coastal erosion because of these dams, plus the rising sea levels and blah blah.
Rising sea level too, yeah. So, any other questions, Holly?
Well, there's one from Bonnie which says if somehow a mega dam were removed, would the return of the freshet reverse these warming conditions, or is it too late?
Yeah, it would, but it would take a little while. But you
You-
have to start sometime.
Yeah.
Yep.
Okay, I see Becky Bardovics.
Hi, wonderful. I got late because I had the wrong connection, so I missed a lot of this, but I have been part of some of this conversation before. And I think, on that note, Roger, isn't there one, or Cliff, one of the two of you, isn't there one of the big dams that's maybe up the Grand River, and I forget which one of the reservoirs that one particular one would make, if we could remove that one, or if that one could be removed, would make a huge difference.
Well, we can talk about the Klamath River, which
Well, I mean, that's Klamath, but I'm talking about up here in the
I know,
Arctic.
yeah, and I do think that when they did, they went after the company in Maine that's the largest hydro dam builder, and they made them to pull some. They made them put fish ladders in on the Penobscot, but the issue is, I don't know of a major river in Maine, where the whole river was undammed yet. I know we may have one, maybe, but I think most of them still have dams on them.
But Roger, wasn't there a particular one that you and Stephen Kasperzak had identified as being something that would make a very large difference if that one particular dam was taken out?
I think the Brisset Dam would be the biggest because they diverted the river, which flows into Agave Bay, and that directly affects, that's right there at the Labrador Current. So that was to us, seems to point the tipping point for what happened. Of course, it wasn't just that, but you had the Nelson River, all those dams on it flowing the Hudson Bay, then the LeGrand River dams, so then you have what's coming out of the Gulf
Look at
Stream.
the Brisset, those cascading dams on the Brisset and the Nelson River, that would make a huge difference for the Gulf of Maine.
Yeah.
That's the point that I didn't hear you say, Becky. The Gulf of Maine, right?
Yeah.
So if we took the dams out up there in those two regions, the Gulf of Maine would improve. Yes.
Okay, I see a hand from Barry Darby.
Yeah, hi Roger. No, I do some research on the Newfoundland fishery, and I was unclear as to the relationship with the subject of your talk and the collapse of the cod fishery and what's happening in the Newfoundland fisheries in the last 2 or 3 decades. The recognized reason for the cod stock decline and other fisheries as well is credited because of climate change and particularly overfishing. In other words, man activities over the last 30 or 40 years in the Northwest Atlantic, and not to anything associated with climate in the first place, but there are climate effects happening now. So I'm not sure that you'd get very much agreement that that megadams are in some ways responsible for the cod collapse or other changes in the fisheries off Northwest Atlantic.
Okay, Becky?
Barry, I'm just interested in you saying that. I have tried to get some traction with the Gulf of Maine Research Institute on just looking at what's happened to, the Labrador Current and the impact of the Gulf of Maine. But I'm wondering who, some of these people are just refusing to look at the dams. And I'm just wondering, I'm sure there was overfishing. We're going to see a lot more of it because all the regulations have just been removed in the United States. But I'm not sure where you're calling from. But
St. John's, Newfoundland.
Yeah. So from what I have a friend who sailed around Newfoundland 2 years ago and said that the amount of lobster and the amount of cod that they could catch, off their boat and, Arctic char was amazing compared to what we have down here. So
yes, the lobster fishery in the last 3 or 4 years has tripled in size.
Yeah.
Because they all moved up from Maine.
Yeah.
Right?
It's because they all moved up from Maine.
Well, no, no, they don't. They
I'm
don't.
kidding. I'm
They
kidding,
can't.
Barry.
I know. I know.
But
But
what
they've
I'm
actually, no.
the thing I think is that there's a certain parameter that these scientists are willing to look at, and and there is a political reason why they are not willing to look at the impact of the dams. And that's because I think the Hydro-Quebec and the dam owners have an outsized influence on some of these organizations. That's maybe crazy for me to say, but that's what I think.
Yeah. The relative size of water movement, the intermixing of different waters for nutrient production, um, this is the reason why the Grand Banks has been such a wonderful source of protein for the world over the last hundreds of years, is because of the interaction between the Gulf Stream and the Labrador Current, and the water flows, both in volume and in volume in particular, is massive compared to freshwater flows. And so I don't see, just from a relative size basis, how the amount of water that flows in rivers can have any effect on ocean currents that are many, many times larger.
Well, I don't think it's just the amount of water we're talking about, but the temperature of the water as well. Cliff?
Oh,
And
the Gulf Stream is a lot. The difference between the Labrador Current and the Gulf Stream would be greater than the kind of temperature changes that you get in some of your rivers.
those rivers that you were referring to, Barry,
Which rivers?
all the rivers up there, the major ones, all of
No,
them.
I'm talking about the current, the Labrador Current and the Gulf Stream.
Yeah, all of the major ones coming out of Canada that have dams on them. Those are not rivers anymore.
They're not what?
They're not rivers anymore.
Of course not. They have I
They're
mean,
reservoirs.
all dams have major effects on what they were like before the dams were put in there. There was all kinds of dams around that are dammed here where there used to be seagoing trout and salmon and everything else, and the rivers have destroyed them. The dam, I've got dozens and dozens and dozens of rivers, dams on rivers in Newfoundland that have caused all kinds of destruction. The question I'm asking is whether or not that has any material effect on the demersal field
The
in the
volume,
Atlantic Ocean.
the volume you talked about is in much, much greater now of fresh water going in to the bays, Hudson and James Bay, and into the Siberian bays that go into the Arctic. That volume is much greater than what you have been used to. And that's
And
just
the
one
rainfall
reason.
but that would because the rainfall is increased?
No, no, because of all the permafrost that's melting and adding fresh water, and all of the smaller tributaries that are flowing into that now. That's why. And the volume is 10 to 20 times greater in the wintertime than ever before that's going in. But it's also the wrong time of year.
Well, I
So
get that, but,
all the marine life is used to being fed in the spring and summer. And all that water is stored and it loses nutrient content and loses oxygen and is chemically changed while it sits, especially the water that cascades through several dams.
I think
Now
that,
that is not being accounted for.
no, I
no,
think that
I
what
know,
you're,
but one of in the saltwater, the effect that has on the saltwater, for example, I grew up in a small fishing community, and there was a harbor, and every 6 hours, the tide rises and falls about 2 to 3 meters.
Hmm.
And the flow, where there's channels, the current becomes very high. The water is moving, and the amount of water that flows on any small harbor on the south coast of Newfoundland, the amount of water that moves back and forth is way more than what flows in the St. Lawrence River. It doesn't go any very far, but it does move. And it intermingles, it mixes, it changes. And you do have these two, what I would call ocean rivers, the Gulf Stream and the Labrador Current, that are, 2/3 of the ocean, the 2/3 of the planet is covered by water. the water that flows in rivers are a minuscule part of that amount of water.
Hmm.
You know,
Yeah.
there are the major rivers of the planet are all segmented and dammed now of the entire planet.
No, but the ocean rivers aren't.
That's
Yes,
true. The
they
ocean
are.
rivers aren't dammed, but they are being affected. Roger, do you have anything you want to add to this discussion?
Roger, yes, you were.
I was just, Noy said it was too complex. It's very hard to get all the information together.
Hmm.
Going back to what was a question earlier, the 90%, well, it's what was it? Rosengert. It was the Russian fishery scientist that said if you ruin the spring freshet, it's going to destroy, especially in consecutive years, it's going to destroy your fishery, your coastal fisheries. It happened in the Aswan Dam in Egypt. It's happened in the Black Sea, in those rivers flowing south in Russia. So, yeah, it needs to be talked about and studied more. I think there were some studies in Norway about damming of rivers and how it changed cod over there. So I think there are studies that have been done, like on embryo of fish, how the flow regulation affected them. But but the fact that it happened 93 and it was all of a sudden, it's just it's odd. I'm not gonna,
Too
I
coincidental.
Yeah.
yeah, it's coincidental, but it's coincidental. It's all over the world. Just it happens.
Isn't that because we're burning fossil fuels?
No,
I
well,
mean,
it's
that's
like,
what everyone has been told.
well, that has an effect. It's warming, but you throw this dam equation in there, and it's specifically targeting the Arctic, and that controls basically the climate of the Earth and the thermohaline circulation, and the rivers are one of the most important aspects of that thermohaline circulation. Also, the freezing of the salt water each winter that's part of the current, the global pump. But with these rivers and these dams, you're messing with the global pump, and that's what Noy was saying. And so, I'm like the messenger for Noy. I'm just
Yeah.
and
I think
and others.
the concern I had was that the attribution of the problems that we've had with fisheries off the east coast of Newfoundland being somehow being able to be fixed by uh, doing things to our mega dam or the way we dam our rivers, I think if that diverted our way from the two reasons which everyone here seems to agree is that the fishery was wiped out in a lot of cases through overfishing. I mean, this is documented over and over and over again. I don't think it's arguable. And two, that the excess use of fossil fuels over the last 50, 60 years has caused the world's climate everywhere to warm up. And of course, if it warms up, and the warming effects are felt everywhere, including the Arctic. I'm worried that focusing on mega dams as a reason for those things, because dams do have all kinds of effects, bad effects on the local environment around the river and the fish that flow in the rivers.
Mhm.
But I don't know if we should try to blame megadams for things that we humans are doing to the rest of the planet through climate change, burning of fossil fuels, and things like that.
It's
And
not
overfishing.
intended, Barry. I don't think it's intended to be an either or thing. We're not, discounting the effect of burning fossil fuels and the increase of CO2 in the atmosphere, but I think there is sufficient evidence to warrant more attention and more concern to the effects of mega dams because they are multiple effects and they are a contributor to climate change, which can't really be denied. And and it's not really recognized because just everyone recognizes the vested interest of the fossil fuel companies in continuing to maintain their profits, through selling fossil fuel products. But there's much less attention being paid to the vested interests of, for example, the provinces in Canada who are the owners of the dams on the rivers, and this is having a global impact. Same
Um,
as in Russia, that the impact
I
on the
would,
Arctic Ocean that's global.
yeah, I would worry that the oil profiteers would see this as a chance to divert the attention away from burning more fossil fuels because that's not the problem anymore. The dams are, and that would be right down their alley to say the cause of climate change is mega dams.
Yeah.
Anyway, uh,
Yeah.
a bit of work. Like I said, I'm worried about the we've overfished here. This is human beings. We caught too much fish. We've used too much technology,
Mm.
and that's what destroyed our fishery in Newfoundland. And I'm worried that people would be diverted away from the real reason for that collapse because they're thinking about mega dams.
Well,
Anyway,
I think, go ahead,
Sorry.
Becky. Yeah.
I don't think anybody's trying to suggest that the fossil fuel industry has our dependence upon fossil fuels has not caused the kind of climate catastrophe that we have. But I think it's that this is an unrecognized other impact, and there's so many things that the dams do to the ocean and to the atmosphere that are unrecognized and are and especially since there's continuing to plan to build more dams, those need to be recognized.
Mm.
And I think the cascading thing, I know the La Romaine has 5 dams on it. That used to be the best salmon fishery along the St. Lawrence. I mean, the impact is it's like everything has a reaction downstream,
Mm.
every bit of it.
Mm.
And whether it's, maybe it's not that, I mean, it's another thing we have to focus on.
Mhm.
And we can't just do one thing because we have been so ignorant about how everything interacts with each other. And to me, this is a really important thing for us to raise concerns about. As in the United States, we're talking about, and in many parts of the country, we're talking about allowing these mega dams to be considered clean energy, and they're not. And
agreed.
the impact that they're having on the indigenous populations and the ecology and the ocean are so huge that they can't be considered clean. And that is that's the problem, is how we get this message out. What we have to do is reduce our energy use, and
Mm.
it's pretty easy to do. It's just not sexy enough.
Mm. Any other input from anybody? Questions or comments or whatever? Because we're going to wrap up pretty soon, but I'm going to.
I did have one more comment, if you don't mind.
Sure, Doug.
Roger and I have had some discussions about the Three Gorges Dam in China.
Mhm.
There's a documentary that about the construction of the Three Gorges Dam in China, which is the largest concrete structure on the planet. That dam, when it became online, altered the rotation of the Earth measurably.
Mhm.
That one dam. So I understand what Barry's concern is, that perhaps dams are a small fraction of the problem, but that one dam literally altered the rotation of the Earth measurably. So I'm not going to believe that mega dams can be exempt from blame in this recipe. And I think the most important part is to get it included in the models
Mhm.
that are trying to model the damage that's being done. It
Mhm.
has to be included. I think that's an important factor. But my last comment on this is that, with regard to fisheries, is that dams aren't a long-term problem. They're an immediate problem. As soon as you commission a new dam, the fish cannot get past that dam. The fish are done. They cannot spawn. So it's not on a time scale like global warming is over a period of decades or maybe hundreds of years.
Hmm.
But a dam is instantaneous. As soon as you commission a dam, the fish can no longer swim the way they used to, and they no longer get the nutrients that they used to get. So it's not just a global climate change problem, it's a light switch. The
Right.
dam instantly kills the fishery. So it's a light switch. It's not a time scale problem. So the dams have a lot. I blame them for a lot, and I agree that we shouldn't feed the fossil fuel industry with excuses as why they shouldn't be, working in the right direction. I agree with that, of course. But my opinion is that this has got to be considered as part of the contribution. So, and Roger and I've had many discussions about this. Thank you.
Thank you. Thanks, Douglas. Appreciate
Just,
that perspective.
one more quick point,
Hmm.
Douglas. Right now, they're finishing up construction on a dam that's 3 times as big as the Three Rivers Dam on the border of Tibet and China.
Yes.
3 times as large.
Right, and they'll continue to make bigger and bigger ones too, and that's the trend. It's not the trend is not in the correct direction of removing dams and trying to find the dams that are causing the most damage, because no one's even acknowledging that they're a problem.
Right. I completely agree with you on that. You're talking to the choir to most of it.
Yeah, I'm sure I am. I'm preaching to the choir, but I just want to, address like Barry's concern about how much are they contributing to the global, picture. And I think that I think it's bigger than what that we can even bigger than the data that Roger has provided us. I think the
Yes.
problem is bigger.
Yes, yes. And the biggest problem is that people use the word climate change. And climate change is a bunch of very specific things. We have to talk more about the specifics and not the general word of climate change. Oh, it's because of climate change. No,
Right.
there are specific reasons.
And like I said, this is having a direct impact on the fisheries. I'm here in Maine and I'm looking at, can you please remove some of these unnecessary dams, legacy small dams, just to let the herring run the way they used to? And there's some evidence already that removing some dams and the herring start to come back quite quickly. I mean, I don't know how anybody can suggest that this wouldn't happen. We could get those fisheries restored fairly quickly if we could just remove some key dams.
Yeah.
You're right, 100% right.
Okay, with that, I'd like to thank everyone for coming today, and thank you, Roger, for putting this together. And we hope to see you again next month at our third and final webinar on the series. You can find all the information on our website, hydrodamtruth.org. And with that, we say have a nice evening, everyone.